Okay, grade 12's last kind of grade 11 2D trig revision question. In the diagram alongside, prove that. Now, we've already had a couple of questions where we've had two triangles and we've had to move kind of from one triangle into the next. And by move, I mean in this bottom triangle QRS, we've given a lot of information. In the top triangle, not so much. It's a 90-degree triangle, so we're expecting to use sine, cos, tan in its easiest forms. And we've got theta. But in the bottom triangle, we've got a lot of information. And we're going to need to figure out probably what QS is in the bottom triangle and then use it in the top triangle. Okay, well, if this angle here is X, and this angle at S is Y, and this is D, okay, well, X and Y, this here is opposite that one there. So if we wanted to use the sine rule, we'd have to work out what this angle here is. Well, angles in a triangle add up to 180. So this angle over here is just 180 minus the sum of the other angles. Okay, and the reason that I'm working that out is because of that sine rule. I'm thinking, well, here's a side, RS is D, and we've got the angle opposite, X. Here's a side, QS, that we're trying to find, and the angle opposite was easy enough to find. Yeah, if we started using the cos rule, well, we'd need two sides to find a third side. So that's out, and there's no area. So we're pretty much stuck with the sine rule over here, and it's not a right angle triangle, so we have to use one of those sine or cos rules. So let's work that out. Now, the thing that we're trying to find is QS, so by default, I end up just putting that in the top left and going, well, QS over sine of the angle opposite, well, that's 180 minus X plus Y. And you'll see why I haven't simplified that yet, equals, that was a great fraction line, right? Equals, well, another side we got given was RS, which is D, over sine the angle that's opposite that side, which is X. Okay, well, that's all well and good, but let's just simplify this. Bottom part here looks a little bit too complicated for my liking, and this we're not going to do anything with just yet, sine X. Now, sine of 180 minus, maybe you can see it already, but think back to our nice cos diagram. Well, sine of 180 is in this quadrant and the sine quadrant, so it's just sine of the angle itself. So sine of 180 minus X plus Y is just sine of X plus Y, because that's our angle. So our angle is X plus Y is our kind of reference angle. So 180 minus X plus Y is just sine X plus Y. Well, that feels a bit easier. And, you know, we can kind of see that we're going to head that direction as well. So let's make QS the subject of the formula. So multiply both sides by sine X plus Y. So D sine X plus Y over sine X. And that's what QS is. Cool. So that's what that mess is. I'm not going to write it in the diagram. It's too much to write. Okay. Now we need to try and find out what PS is. So PS is over here. And we've got theta. Well, in this nice right angle triangle, here's theta. And this side here is the adjacent side. And this side here is the hypotenuse. Well, to me, that speaks cos. So cos of theta is the adjacent PS over the hypotenuse QS. Now, I'm not going to substitute QS in just yet, because I think it'll be easier to manipulate this equation. What we really want is just PS on one side of our equation. So let's multiply both sides of the equation by QS. Then we'll just have PS. What you do on one side, you do to the other. So here we've got QS times cos theta. Now we can substitute in what we know QS is. Well, QS is this big fraction over here. So that's D sine X plus Y over sine X, and we need to multiply it by cos X. Somewhere my equals went funny. Hey, look at that. That's exactly what we needed to find. And that's a beautiful way to end. See you in the next one.